that's good because on the 17th, actually, it coincides with there's a lab opportunity with the observatory that evening, but that's your last day to turn in 2 labs to get full credit. We were just talking about this semester. I'm a little bit different each semester, but I'm consistent throughout a given semester. So if you have a late lab, you can turn it in, but for every business day late, you'll lose 10%. Okay, so that's kind of how that goes. So of course, it's due on a Friday, which is the last business day of the week. So if you turn it in the following Monday, the most you could get if you turn in an adequate report would be 90%. And then, eventually it's not worth anything. It's 2 weeks.
And
So,
I'm sorry, what time on Friday will you be accepting them until?
Midnight.
Okay, so we do the one on that.
Right. And if you turn it in over the weekend, it'll count as if it's on Monday. Okay. It's like, all these little rules. But notice that actually then there are a few opportunities for your second set of 2 labs that you need. Starting with morning meeting at the Whittick Observatory, the partial solar eclipse, and I'm going to give you some details how to make your own little viewing box. I'll just get off the internet and kind of push it out there. The other thing, the 23rd is on a Thursday, and that's my lab day. And so what works well for me after 3 is to set up a telescope over there, not clear back where we've been, but kind of just right off the parking lot on the hill, and a telescope that's set for solar viewing. And I bought just this morning a new solar filter for my 6-inch refractor. I'm so excited. You can either make your own little box and watch it. It's a partial eclipse, so it won't have totality. Or you can come out with me and see it on the hill. And then, of course, 2 weeks after the 17th, which at the... Oh, no, that's not right. 2 weeks after the 17th, you would have another public viewing there. But on the 29th is a time when, about 6:30, I think I say, my husband and I are going to open up the observatory for you out there in case you're interested. All right. So, yes, there is discussion out there. The textbook, which, remember, its copyright is 2015. Don't blame me. I like Bennett's book, but I don't like how fast they keep coming up with new editions. So it's really been kind of walk in step with what I'm used to with the previous edition, except for they inserted in chapter 10 now, instead of being the sun, chapter 10 is actually extrasolar planets, planets that orbit other stars. So we're going to be skipping chapter 10 as it is in the textbook we're using this semester. So what that means then is that we'll still have what I used to teach, basically, but instead of being 9, 10, 11, 12, as my syllabus says, and I'm going to update my syllabus this weekend and give it to you on Monday, now my syllabus is going to say Unit 3 is chapters 9, 11, 12, and 13. The other thing, and I'll try to explain this, so just go ahead and stay calm. The other thing is if you are printing out the slides, which I hope you are, okay, notice that, and maybe this will help emphasize what I'm trying to say. Notice that when you print them out, although the files will say chapters 9, 11, 12, and 13, when you print them out, what your file for chapter 10 will say, okay, for your file for chapter 11, will say chapter 10. Okay, so I'll say PPT for PowerPoint will say, this will say 10, this will say 11, and this will say 12. Okay, so don't freak out. Well, you can freak out, but don't take it on me. Okay? All right. So, on to the next part of the story, which I think science is like one big story, whether it's astronomy or chemistry or meteorology. So the next thing we get to talk about in the story, we get to hone in on those little crumblies that were left that didn't end up becoming planets from the solar nebula, kind of leftovers we call.
Of course, that includes basically asteroids and comets. Okay. There is, and I'm going to see how our internet, see if our internet's behaving. I thought it should. Right now, remember I said that there's a traffic jam up there on Mars, which is kind of fun because related to that traffic jam, it coincides there is a comet that is, they've double checked to make sure that comet's not going to run into Mars, so that's a good thing. But there's a comet that is going to have a close call to Mars. Okay. And it's called, well, it looks like let's try one more time. And it's called, actually comets have names, and they're usually named after who finds them. This one is called Sighting Spring. Okay, so there's a website under my science Twitter feed that actually shows you kind of information about that. Okay, the other thing, and for some reason the internet is not cooperating right now, but the highlight in blue, actually there's a NASA mission called Dawn that has visited Vesta. Vesta and Sirius are the biggest asteroids in the asteroid belt. Okay, so it visited Vesta, now it's on its way to Sirius. Sirius is a dwarf planet, okay, and so it's going to get some good pictures of Sirius. So how do they see asteroids? So the thing about seeing an asteroid is similar to seeing a planet. Planets don't glow. Planets basically take the sunlight and send it back to us, okay? So the only reason we see an asteroid is that sun is reflecting off of it. So if you have basically, if you are privy to an asteroid, it will move against the background stars, okay? Asteroids are out there kind of moving, and we can get them using time-lapse photography, basically. Asteroids. There's a few fun facts about asteroids. We're going to talk ultimately about 3 different places asteroids are, not just the asteroid belt. There's 2 other types of asteroids depending upon where they're located. One thing about it, you might be kind of curious, is if you were to take all the crumblies, all the asteroids, and try to say, I want one more planet, give me one more planet out of all those, for instance, asteroids in the asteroid belt, it wouldn't happen. It wouldn't be big enough to really be what we call a planet. Small planet even. So here's some photos of asteroids. And if I were to ask you what moons they look like, you might tell me Phobos and Deimos. Kind of the whole potato-looking thing. And for something to be round, usually it needs mass and it needs time. Okay, mass will give it the gravity and needs a little bit of time to kind of make itself spherical. So this is adorable. This is an asteroid. And you can see asteroids on those pictures and this picture, actually they have pockmarks. Asteroids have been battered just like our moon has been battered. You know what?
From everything else in the orbiting around and hitting you,
Mm-hmm.
crashing.
And then actually this asteroid has a buddy. Okay, this asteroid has a satellite that's orbiting that asteroid. Isn't that adorable? I think so. So I said there are 3 types of asteroids based upon where they're located. Most people are all real cool with the whole asteroids. There's a bunch of asteroids after Mars and before Jupiter. We call that the asteroid belt, main belt asteroids. But there's 2 other places that there are asteroids. There are asteroids kind of escorting the planet Jupiter. They're in Jupiter's orbit, but we call these stable Lagrange places. Okay, they're called Trojan asteroids. And then there are the wild child. Okay, the Apollo asteroids. It seemed like I should be able to say a cuss word there, but I didn't. Okay, so the Apollo asteroids are the asteroids that they aren't in the belt and they aren't in Jupiter's orbit. Okay, they are just kind of a little more random. These guys are our near misses. Might make sense. One more time. So even if this doesn't open, I want to kind of assure you, with these near misses, especially with the Apollo asteroids, that NASA has been mandated by Congress to keep an eye out for those Apollo asteroids, those near misses. And they do a pretty good job. They have a website out there where they say what the close misses are. But if you ever hear them talk about NASA's NEO program, okay, NEO stands for Near Earth Objects. Okay, so those are the close misses. And what this website says is, and it's kind of interesting, it has two tables. I saw it recently. The table where the close calls have already come and gone, and the table where they're upcoming close misses. They will tell you what size it is. They'll say how close it is. So what you're looking at here is the sun is over here, and then of course we have Mercury, Venus, Earth, Mars. Okay, and before we get to Jupiter, we have that asteroid belt. So that's kind of what this is. So we have the sun, sun over here. Okay, Mercury, Venus, Earth, Mars. So you're kind of looking at tracks. Okay, so right here, this is the asteroid belt. So if we're kind of looking at tracks, basically the asteroid belt has some kind of sweep positions where they are very heavy with regard to the number of asteroids at that location. These sweep places are like what we call a resonance created by the presence of Jupiter. Okay, so all those little white dots, okay, would be representing those belt asteroids. Asteroids in the asteroid belt. Okay. And like the slide says, that even if we use the word accretion as to material kind of coming together to make a planet, even if that material did want to accrete to form a planet, actually Jupiter's kind of screwing it up with regard to the influence of its gravity. Jupiter's pretty darn big. Jupiter can be a bully if it wants to be. So if you're like me, you might look at this and you're kind of like, it looks like it's glowing up there. Okay, so it's not glowing. It's not a science fiction, okay, sort of thing. But this actually is a chunk of rock that came from outer space. And I'm not necessarily going to convince you of how we know a rock here on Earth came from outer space, but there are ways to know. So all those kids are grabbing onto that thing that looks like it could open up and something could jump out of it. Things that we pick up, rocks that came from outer space and survived the passage of Earth's atmosphere, we call meteorites. And I think that's probably on the next slide, I think. So 3 terms, when I look at things that I want you guys to know long term, this is one of them. We're going to talk about meteor showers here in a minute. But the previous slide, the kids touching that object, that was a meteorite. Okay, it survived Earth's atmosphere. You can touch it, just like those kids did. In the past, I've had students bring up rocks. They're like, dude, I just know that this is a meteorite. I'm like, it could be. That you need to send it to University of Iowa and have them check it out. The opposite of a meteorite is a meteorong. I didn't think of that, really. Okay, so then let's kind of turn our attention to a meteoroid. Okay, notice oid. So if you're kind of thinking space stuff, you've probably heard of asteroids. Okay, asteroids are rock. A meteoroid and an asteroid are related, very much so. The only difference is relative size. Asteroids are big rocks, meteoroids are little rocks, but they're floating around there in outer space. Okay. So this is in outer space. Oh, I say up there, don't I? So then all we have is a meteor. And this actually is short-lived. And this is the falling event. Ooh, Falling Skies, that's a great show too. I'm behind in watching some of my shows. So the meteor is the streak. Oh yes, they call it the streak. Okay. So basically, when the rock falls through the Earth's atmosphere, it burns up, and depending upon its trajectory and how big it is and what it's made of, it'll be a long streak or fast streak. They come in oranges and yellows and blues. There. So meteor is the falling star. Have you ever heard that term? Almost romantic. But you see, it really has nothing to do with a star. The thing about it's not a falling star is if you were to go back in time, there would be no star there to have fallen. Okay. All right. So the rocks that you pick up are called meteorites, the things from outer space, the little bit that survive the Earth's atmosphere. Sometimes they're big bits, sometimes they're little bits. And scientists have studied these rocks and kind of categorized them as being pristine or unaltered since basically our solar system began forming 4.6 billion years ago. And then there's others that, as they've been part of their asteroid or meteoroid through time, they might have had some things going on. Actually, what falls under processed meteorites is we get meteorites from the moon and Mars. Those would definitely be processed. So these are example of primitive meteorites. Okay, so there's kind of a couple different flavors of primitive meteorites. Pretty. And these are processed meteorites. And I mentioned I'm probably not going to convince you, nor could I go to the lab to say, oh, that's a meteorite. But it has to do with assaying it. Assay just simply means putting it in a black box and seeing what it's made of, what its chemical properties are. And they don't match what the rocks on Earth are. So either an alien came and put them there, or, you know. So kind of similar, it goes back to assaying. Okay, so we identify a rock on Earth right now not being from Earth because of its chemical properties. Similarly, we can backtrack the characteristics of that rock back to either Mars or the moon. Like, really? I'm like, yeah, that's pretty cool. And then you get to thinking, you're like, well, how would we have a little piece of Mars on the Earth? And then the answer is you have to kind of go back to what we talked about, that chaotic time in our solar system where things were bouncing other things. Okay, Mars would have been going ahead and forming a crust, but there's still things whacking it. Okay, so basically once it forms a crust, it gets whacked, and then some of that stuff flies off and ends up coming in our direction. So I know it's a lot, but there you go. I heard a statistic recently. I think is it 100,000 tons? That might be on the light side, but 100,000 tons of stuff falls through the atmosphere and hits the ground from space every day. Like, really? Like, have you ever heard of the term micrometeorites? Micrometeorites, basically little tiny stuff that doesn't make a streak, okay? But it doesn't burn up, and it's little tiny stuff. And if you go on the internet and search micrometeorites, there are ways to go ahead and try to capture these micrometeorites and identify them as being so. In that, what I've read about micrometeorites, knowing that you have a micrometeorite, is using what biologists use a microscope. And you can kind of see the kind of spikies, so it's kind of fun. All right, so switching gears. This is a still image of a comet. Okay, so all comets are different with regard to color, with regard to kind of their characteristics. Up here, this is what we call a coma. And of course, you guys would call this the tail. You'd be right. Okay. Some comets, when they get close to the sun and they're doing this, they're fizzing, they only have a coma part. Some have a small coma and a long tail. The thing about comets is that, how do I say this? They aren't like a jet contrail. You know what a jet contrail is? A jet goes across the sky and leaves a... The thing about comets is even though they are in motion, the reason they're fizzing is because they're too close to the sun. They're either gonna go around the sun, okay, or they're on their way away from the sun. So they are moving, but they're moving, how do I say this? They're far enough away that parallax makes them not move much. So the thing about a comet is we might go out one night and we find it here. The next night we find it here. The next night we find it here against the background stars. So in a given evening, it's not going to be like a meteor and go streaking across the sky. That was a realization for me, you know. It's like, yeah, that's right. That's how that works. And so what you do is like look in magazines, like astronomy magazines, or on the internet, and they would tell you a map for this is where it is today, this is where it is tomorrow, this is where it is the next day. And you can find them through one way or the other via telescope or sometimes from binoculars. Okay, so comets, what are they? Well, we kind of talked about them before, and we're going to talk again about the Kuiper belt and the Oort cloud. We're going to talk about those two sources of comets, where they're hanging out. So this is a good time to point out when the comet, those little icy, rocky things, when they're in either the Kuiper belt or the Oort cloud, they're too far away from the sun. They're not fizzing, okay? So those things are just, they have no coma, they have no tail. They're minding their own business. This is kind of neat. I wonder if I have any belts here. Oops, let me go back. I know it's on the next slide, but this is called the nucleus, and can you kind of see the fizziness here? I watched a cool video recently where somebody made a comet that would fizz by simply taking an assortment of liquids and rock and soil and putting them in a bag and then using dry ice to cool it down to a chunk. Okay, then she took it out and then she put it in front of a heat lamp. Okay, and it started to fizz. I say fizz, but basically it's gases coming off. Okay, so there's the nucleus. It's got too close to the sun. But don't they look unpredictable? I mean, scientists can have a sense for size and all that of the nucleus of a comet, but you don't know where the little jets are going to be. It's definitely not homogeneous. Okay, so things that you need to know about comets when we kind of pick them apart, important parts of a comet. You need to know this is the nucleus. Okay, the nucleus is the rocky part, rocky, icy. I'll just put solid part. And when we talk about the solid part of a comet, you know, we're talking about rock and ice. That's why we call it a dirty snowball. And then we have the coma, and this one doesn't have as much of a coma as the other one. Now I might would kind of call this the coma, kind of elongated coma. But then there are two tails. Okay, we see the plasma tail, and then we see the dust tail. Okay, the dust tail has a little bit of arch to it, and the plasma tail is straight back away from the sun. So actually, I think I might have it the next slide. It's emphasized, but actually it's on this side. In this drawing, like this said, the sun is up here. Okay, we know the sun is up there because the plasma tail is going right here. Dust tail kind of arches like that. All right. So this is showing a possible path of a comet orbiting the sun. So in the middle here, okay, is the sun. And we show the sun spitting out a couple of different things. We've talked about the solar wind, that's represented in red here, and the energy, the radiation, is represented with little yellow squiggles. The sun's doing its thing in all directions, including the direction of the comet. So I like this because do you notice out here, that comet is just all intact. No fizz. Okay. It gets close to the sun, it develops a coma. It gets even closer to the sun, more of its stuff's coming off, and you can start to see a tail. Now, most comets I've seen are all coma, and not much tail. But the closer it gets, notice that these little crumblies coming off here, Okay. That is the dust tail, and that is the plasma tail. But do you see that over here, as it starts to kind of go